So we talked about the mole and how the mole is defined as the number of atoms in 12 grams of carbon-12. Now, if we take that definition and we kind of tweak it a little bit, we can actually come up with something very useful, and that is molar mass. Molar mass is the mass of 1 mole of a pure substance, okay? And it has units of grams over moles. Haha. Now, we're going to talk about that too. But I want to work through something with you for a little bit first, okay? Let's go back to our marble example. And we had 25% of all marbles have a mass of 2 grams. And 75% of all marbles have a mass of 3 grams. Now I'm extending this out a little bit to say 25% of all marbles and not just 25% of a box of marbles, which gives my average mass of 2.75 grams. That's my average. Okay? Now, let's say that I have 1 marble. Is 1 marble going to have this mass? Well, no. 1 marble is either going to have this mass or this mass. Okay? Now, if I just randomly grab 10 marbles, am I necessarily going to get this mass? Well, no, not necessarily, because let's say that just because the way I grab it, I end up with 5 and 5. Okay? That is not going to give you the same mass. Okay? This would give you 2.5 grams. All right? Well, what about if I had 100 marbles? Okay? If I grab 100 marbles. Now, if I grab 100 marbles, I should get closer to this 25% and 75%. I should end up closer to 2.75 grams. What if I grabbed 1,000 marbles? I should end up with this average, closer to this average. Well, what if I grabbed 6.022 times 10 to the 23rd grams, or marbles? I should end up with exactly this average, okay? It'll be good to several decimal places because I should end up with 25, maybe like 25.0000001% of the marbles have this mass, and 74.000 or 999999998 would have that. Okay, so then the greater number of a sample that I have, the closer that I can get to the average using the percent abundance. Okay, so what I'm trying to get at here is that the molar mass should have the same value as average atomic mass. Okay? Now, they mean very different things, but I should end up with numerically the same thing. Okay? Now, molar mass means the mass in grams of 6.022 times 10 to the 23rd particles. Okay, so let's say that these particles are atoms. Okay, so the molar mass would be the mass of 1 mole of those particles. Okay, well, average atomic mass is the average, the weighted average of one atom. Okay, so this is the mass of 1 atom. That's average atomic mass. Molar mass is the mass of 1 mole of atoms. Okay, so they mean very different things, but they still have the same value. Okay, that's something that's very difficult for people to keep in mind. Okay, but that also means that I can go to my handy dandy periodic table and say that these these numbers under here are also molar masses, okay? Sometimes molar mass is also called atomic weight, okay, or molecular weight for larger compounds, okay? But I'm just going to stick with molar mass because that's always true, all right? And you see that molar mass has these units of grams per mole, all right? Now, that should be setting off alarms all over the place, like, hey, molar mass is a conversion factor. Ha! That is true, okay? Molar mass is a conversion factor, and you can use it as such. So, how many grams are in 6.64 times 10 to the third moles of potassium? Okay, this number should look familiar because you calculated this a little while ago. So this looks like it's set up to be dimensional analysis again, right? Because it's the same kind of style that we've seen a lot. So question mark grams potassium equals 6.64 times 10 to the third moles potassium. Okay? And then I need to write some mole potassium down here. And, oh, can I go straight from grams to moles? Well, yes, I can use the molar mass, grams potassium up here. Okay? Well, where do I get the value for this from? That's from the periodic table. Okay? So here's potassium. Here's that average atomic mass or molar mass. And by the way, molar mass is what we're going to use all the time. So just remember these things as molar mass. And for this unit, remember it as average atomic mass. Okay? So the molar mass of potassium is 39.098 grams potassium per 1 mole potassium. So remember, the equality here is 1 mole potassium weighs 39.098 grams of potassium, okay? So that's our equality, and I've turned that into the conversion factor that we need, okay? So I'm going to go ahead and plug this into my calculator, and I get 2.60 times 10 to the 5th, okay? I'm going to use 3 significant figures from this. Okay, your molar mass should very rarely limit your calculations because, so I give you a periodic table with 5 significant figures for most things. Okay, even something like lithium, the next digit is a 0. Okay, so we keep these things in mind. Don't let your molar mass limit your calculations. Okay, that's just generally not done. So my leftover unit is grams potassium, and let me just quickly check. So this is, let's say that's 7 times 10 to the third times, this is close to 4 times 10 to the first. 7 times 4 is 28 times 10 to the fourth. This number has to get smaller by 1, which means this has to get bigger. So this is about 3 times 10 to the fifth, which is in the correct power of 10, okay? And this rounds up to 3. So this check tells me that I'm good, all right?